Okay, so in the previous part, we figured out a number of things. So here is my current, here's my current situation. I know my current situation that I've got a pressure of 0.95301 atm. I know that my volume is currently 533 liters. This is the fluorine gas, takes up 533 liters of space. I know that this is 20.76 moles of fluorine gas. And I also know that my current temperature is 298 Kelvin. All right, and what my goal is, all right, I only have one goal. And my only goal is to get the volume to 300 liters. And I could change anything else. I could change the pressure, I could change the moles, I can change the temperature. And we listed briefly exactly what we might do in terms of increasing or decreasing those amounts. So let's see if those play out. All right. Now, there are many different ways that you can actually do this. I'm going to show you 3 different ways. All right. So the first way you could do it, so let's work on the pressure first. All right, let's just say I want to change the pressure. So I'm just thinking about this conceptually. If I want to squeeze the volume from 533 liters to 300 liters, like I have here, I'm going to need to apply more pressure. So I know my pressure is going to go up from 0.95. All right, so once I've established that and I've thought about it a little bit, I could do this in a number of ways. You could memorize this formula, which we derive from the graph, which is P1 V1 equals P2 V2. So in other words, the pressure times the volume currently, will equal the pressure at the goal, which I don't know, because I don't know how much pressure I need to apply, but I do know how much volume I need to get to. And so I could solve it this way. So if I'm doing it this way, let's say I memorize this equation. So if I memorize this equation, I can just use it now. All right, I can just use it immediately. So I say, okay, 0.95301 atm. I have the original volume, which is 533 liters, equals pressure 2, which I don't know because that's what I'm trying to figure out. I need to know how much pressure I need to add. And I'm going to multiply that by my final volume, the volume of my goal, which is 300 liters. And so I can solve for pressure 2, basically. I want to get that alone, so I'm going to divide both sides by 300. And if I do that, that cancels. And so I can calculate 0.95301 times 533. That gets me, divided by 300, sorry, made a small mistake in calculation. So let me do that again, 0.95301 times 533. Divided by 300. All right, perseverance. And so I figured out that pressure 2 is actually equal to 1.6, and I've got 3 sig figs, it looks like, so 1.69 atms of pressure. And just thinking about whether this makes sense, my pressure was originally 0.95. I wanted to increase the pressure to get the volume smaller, and indeed the pressure has increased. Okay, so again, this is if you memorize the formula. Boom, you've got it. That's great, you're done. But what if you don't remember the formula? All right, well, you should remember this one. And that's the only formula you actually need to remember, because you can derive this from this equation. So what you need to do when you have this equation is your before and after are going to equal a constant r. Okay, so I can rearrange this equation around the constant r. PV over NT equals R. Equal NT, NT, that should be a T, equals R. Because I know that if I do this, it's got to equal R. That's what the equation is telling me. I just divided both sides by NT. Now in my current, I'm going to call that current situation 1. So here's situation 1, here's situation 2. Well, if this is true, then I know if I take my pressure from situation 1 times the volume from the current situation, divided by the moles of the current situation, times the temperature of the current situation, that has to equal R, right? And I also know that R is also the pressure 2 times the volume 2, and 2T2. So whatever I have here, if I put them in the equation like this, they also have to equal R, this constant. So basically now, since they both equal R, All right, they have to equal each other. So I have P1V1 equals P2V2 equals N1T1. Sorry, I'm not sure what I just said, but P1V1 over N1T1 equals P2V2 over N2D2. They have to equal each other. So far, I've only used this equation, and I did some fancy math. And now, how do I get from here to here? Well, in this one, I'm only changing the pressure. I'm not changing the moles. I'm not changing my temperature. So what I can actually do to get there is cross these out. And what you see is I figured out, okay, if I want to change the volume to get to 300, and I want to change the pressure to do so, this is the equation that I need. So I took this, really combined with everything and made it into that, and now I've got that equation and I can plug it in. All right, so that's a second way to do it. So this is actually really the same way. It's just if I forget this formula. So let me label this as method 1. Method 1 is memorize the formula. Method 2 is to derive the formula from PV equals nRT. Okay, that's the second way. And there's actually a third way, I believe, but yeah, there should be a third way. Okay, so those are probably the two quicker ways. But the third way isn't too hard either, and it might be worth thinking about. So this is a case where I actually know a lot of things. I actually know that I'm not going to add any more moles. So let's just ignore these questions because I'm still doing the same problem. I'm still just changing the pressure. But I just want to show you the 3 ways to do that. And then the rest of these I think you can kind of do on your own based on remembering the formula because they're the same steps, just a different equation. What I know here is that the moles, have they changed? Well, I don't think so. I wanted to send this amount, and I still want to send this amount, so that's going to be the same. If I'm only changing the pressure, the temperature's not changing. I'm still maintaining that 298 Kelvin. And so the only thing I don't know is the second pressure. And so I know 3 variables. I know R, and so I can actually go back to just PV equals nRT. Okay, I can rely back on this formula, and I know I'm solving for pressure. So I say, hey, this is pressure. I'm going to move the volume to the other side, and I'm going to call this P2 because everything now is not what it was originally. This is a new situation where everything is getting to the goal of 2. All right, so now I should be able to plug in everything like I had before. So let's plug in N. N is 20.76 moles. All right, times R. R is 0.08206. T is, sure, let's use green. T is 298. And finally, the volume of what I want to get it to, 300 liters, going to divide by 300 liters, and it should get me the same thing. So let's see if it does. I'm taking 20.76 times 0.08206 times 298 divided by 300, and that indeed gets me 1.69 ATM. So I just had to use this equation as well because I know all the facts. I know everything and what it's going to be. So both of these would work. You can either memorize the formula, you can derive the formula, or if everything is given and you know all these amounts, you can actually just use PV equals nRT. So whatever equation works best for you, or whatever method works best for you, that's what you should shoot for. Now the other two, changing the temperature, changing the moles, you have different equations, but you go about solving them the same way. So you should try those and make sure you can do it. All right, good luck. I hope this was helpful. King out.